Hello friends, today we are going to learn about projectile motion. This topic is very important for JEE and NEET as varieties of questions can be asked. Also, questions can be mixed from other topics such as collision, angular momentum, etc. Like you are asked to find out the angular momentum of a projectile about its point of projection at the maximum height. Also, a projectile, after being projected at the maximum height, breaks down into three particles. Find the range of individual particles. This type of questions can be asked. So let's start. So let's get the basic idea regarding projectile motion. Projectile motion. Projectile motion is the motion under gravity and the horizontal velocity imparted to the particle. Let's understand what do we mean by this. Suppose I have a particle here or something. I am projecting it with a velocity u at an angle alpha. First of all, what is a projectile? Projectile is anything that is being projected or thrown. So I am projecting this particle with an initial velocity u at a angle of projection alpha. Now what will happen? This particle is under the influence of gravity, that is g. So this particle, instead of going straight, it will come down like this. And also there is a horizontal velocity imparted to the particle. So horizontal velocity is imparted to the particle. That means there is a component of this velocity that is acting in the x direction that will make the particle traverse some direction in the x-axis. This is exactly what is meant by this statement. Also, suppose you want to throw a stone somewhere. If you want to throw a stone, then you are definitely going to project it at somewhat like this, say 45 degree with the horizontal, then it will go like this. If you throw it directly upwards, then it will come and fall in your head. Just don't try this. This was just said for example purpose. Don't try this. So this horizontal velocity, that is important to make the stone travel in the x direction. So it will go far if you impart this horizontal velocity component. An independent analysis of x and y components of the motion using simple 1D motion equation. So this projectile motion, there is one y component and x component both. So this is a 2D motion. We will study the x component and the y component separately, or rather we'll analyze them separately, because if we analyze them separately our job becomes easy. So let's analyze the projectile. First of all, we have a particle. This particle is being projected with an initial velocity u and at a angular projection alpha, and also there is a acceleration due to gravity which is acting downwards always. So what will this projectile will not go straight like this because there is a gravity acting downwards. So instead of going straight upward, it will follow this type of path. This motion is known as projectile motion. Exactly this is what you are going to learn. See the path I have drawn here. This path is shown using curved line. Now we can resolve this initial velocity component into ux and uy, where ux is the x component and uy is the y component. Now Here I have resolved this into the x component and the y component. This is u cos alpha, this is the x component, u sin alpha, this is the y component. This we can get by this right angle triangle. This is u, so this is u cos alpha and this is u sin alpha. I have written the results here. Now what we are interested is that this velocity will be changing because there is an acceleration due to gravity g that is acting downwards. What is the velocity at any random point p during its motion? To understand this, we need to, since this 2D motion, there is x and y component, I am resolving this velocity at any time t at any point p, that is as vx and vy. So vx and vy I am resolving it, and also this distance is x and this displacement is y along y axis and on x axis. We'll deal everything separately. So here is the picture. Now one thing we have to understand, that is this acceleration due to gravity is acting in minus y direction. That means its x component is 0, and in the x direction there is no acceleration. So ax is equal to 0 and ay will be minus of g. Why minus of g? Because y is in positive direction and g is in negative direction. That is why. So let's find out the components. We will be using simple equations of motion like v is equal to u plus at. Exactly the same equation we will be using what we used in 1D motion. Here we are just adding vx here we'll be adding here vx, ux and ax to this equation, and here ax is equal to 0 since in the x direction there is no acceleration. The particle is freely projected in the x direction. The component of the velocity is free in the x direction. It is not acting under any force. So vx will be simply ux because this term will become 0. So ux or u cos alpha. So here I can conclude that vx at any point, that is u cos alpha. So irrespective of the irrespective of the position of the particle, the horizontal component of the velocity always remains constant, that is it's u cos alpha. Here also we can say it's u cos alpha. Throughout the motion the x component of the velocity remains constant since there is no acceleration. Now again we have to find out the displacement of the particle in x direction. So s is equal to ut plus half at square. That is the equation we have learnt in 1D motion. So instead of s we will write x. X is equal to ux into t plus half ax into t square. Same thing. Now x is equal to ux into t plus t, since ax is equal to 0. Ax is equal to 0 because there is no acceleration in the x component. So x is equal to u cos alpha into t. So x is equal to u cos alpha into t will give you the x component of displacement at time t. Now applying equations of motion in y component. In y component also v is equal to u plus at. So vy is equal to uy plus ay into t. ay is equal to g. This is because y and g are in the opposite direction, so y is in plus y direction, so g is in the minus y direction. So Vy is equal to u sin alpha minus gt. Here u sin alpha minus gt, so this is similar to v is equal to u minus gt. That is, in the one dimensional motion chapter there was a topic that is motion under gravity. So we are just projecting it upwards, throwing it upwards, and it is coming down. So during the upward journey it was u minus gt. So the same thing we are doing here. We are only studying it for, analyzing it for one component, and an additional component, that is the x component, that is present here. Next, now we are required to find the displacement in the y direction. So s is equal to ut plus half at square, y is equal to uyt in plus half ayt square. Same thing we are replacing, that is uy is equal to u sin alpha. The horizontal component is u sin alpha. Ay is equal to minus of g plus ay minus of g. So y is equal to u sin alpha minus half gt square. So these two are important, how we are getting it. Now we have to find the time of flight. What is the time of flight? Time of flight is, we are launching the projectile and it is flying. It is moving, it is remaining in the air, and now it strikes the ground. Now the time it stays above the ground level. That means, what is the ground level? Here ground level is y is equal to 0. It is staying above the ground level. It is y is greater than equal to 0. Between the 2 points it crosses the y is equal to 0. So this is one point, this is another point. In between these 2 points, this part, it is staying in the air above the ground level. So I will have to find capital T, that is time of flight. Now how did we calculate the time of flight? Let's see. We have just, this is the fundamental condition, that is y is equal to 0. Now what was y? Y is equal to u sin alpha t, ut minus half gt square. So u sin alpha t minus half gt square, that we are equating to 0. Now we have taken out common t, so t into u sin alpha minus half gt is equal to 0. That is simple mathematics. This is a quadratic equation and we'll get two roots. T is equal to 0 and t is equal to 2 sin alpha by g. I will advise you all not to take this half gt square into the other side, like I'm telling you, u sin alpha t is equal to half gt square. This, if we cancel like this step is wrong. We cannot cancel t and t like that, because one of the value is t is equal to 0. So we have to take care, we have to make it a factor, that we have to take t common, and then we have to find out the two roots. T is equal to 0 and t is equal to 2u sin alpha by g. And so I can say that this is my projectile. At this point it is t is equal to 0, and at this point it is t is equal to 2u sin alpha by g. So t is equal to 0 and t is equal to 2u sin alpha by g are the two roots of this equation. So the time of flight is 2u sin alpha g minus 0, that is 2u sin alpha by g. That is the time of flight. This expression is important. Please memorize this. Now, calculation of range. Calculation of range, it is the displacement of the projectile from the initial point of projection during the time of flight. So I'm projecting the particle here, and it is starting here and it is ending here. So the displacement is range r. This is the range. Now let's take another case. Let's put a let's put an inclined plane here. So the flight will stop exactly at this point. So how will be the range? Range will be like this. I will teach you how to calculate the range and the time of flight of a projectile in an inclined plane in a separate video. Just to make you understand the concept of range, I am showing you this example. So range is the displacement of the projectile from the initial point of projection during the time of flight. So during the entire time of flight, how much it is displaced. So how to calculate the range? As we said that it is the the displacement is in the x direction for a projectile on a plane ground. For a projectile on a plane ground, the displacement is in the x direction. Now, in the x direction, during the time of flight, it will be u cos alpha will be the velocity, and there is no acceleration, into the time of flight, that is t. We can say x is equal to u cos alpha into t. Now, when t is equal to the time of flight, x becomes r. From there we can get r is equal to ux into t. So what is ux? Ux is the x component of the velocity, that is u cos alpha, into 2u sin alpha by g, that is the time of flight we obtained earlier. So if we rearrange them, this u and u will become u square, 2 sin alpha and cos alpha, so 2 sin alpha cos alpha by g. So by basic trigonometric manipulation, we will get u square sin 2 alpha by g. U square sin 2 alpha by g. So also there is another variation. I'll show you what is the utility of this variation. R is equal to u cos alpha into 2 sin alpha by g, as we saw in the earlier slide. Now we can separate u cos alpha and u sin alpha and this 2. U cos alpha will be ux, u sin alpha will be uy, and here it is 2. So 2 ux uy by g. We are just considering the components and nothing else. Also for time of flight, I want to say time of flight is 2u sin alpha by g. This u sin alpha is 2uy by g. U sin alpha is the vertical component of the initial velocity. I will be telling you the utility of this two formulae by the help of a question. Now let's do this question. Let's solve this question. A projectile is projected with an initial velocity of u is equal to 3 I cap root 3 I cap plus j cap meter per second. So the initial velocity is given that in vector form, root 3 I cap plus j cap meter per second. Calculate time period and range. So we have to find the time period, make this time of flight. Instead of time period, just make this time of flight. So we are asked to find the time of flight and range. So let's solve this. We have been given a projectile whose, let's say, u has been given root 3 I cap plus j cap, and this is the x component, this is the y component. We are just resolving it, very simple thing. Now how to go for this? You know the formula, r is equal to u square sine 2 alpha by g, and t is equal to 2u sine alpha by g. Now this we have to find, if we want to solve it from this formulae, then you have to find out alpha, you have to find out the absolute value of u, and so on. So this is the approach 1. The first approach exactly says that, suppose we have been given ux, we have been given uy, and we have been given alpha. So this is uy, this is ux. So tan alpha will be uy by ux, that is 1 by root 3, because ux is equal to root 3 and uy is equal to 1. So 1 by root 3, so alpha is 30 degree. And the absolute value of u, that is the magnitude of u, is root over of ux square plus uy square. So that is root 3 plus 1, that is 2 meter per second. Now we have the u, we have the alpha, so time of flight is 2u sine alpha by g, and by substituting the value alpha 30 degree and 2 into, and g is 9.8 meter per second square, we get 0.204 second. And range, similarly we will substitute the value sine 2 alpha, sine 2 into 30, that is 60 degree, it will be sine 60 degree inside, and 2 square sine 60 degree by 9.8, that value will come out to be 0.35 meter. However, we had a lot to do here. We had to find alpha, we have to find u, then we have to find t and r. Let's see if there is an easier method. See the approach 2. Here we will just play with the components. We have been given the ux and the uy, x and y component. See the time of flight. Time of flight is 2u sine alpha by g. As I told you, u sine alpha can be written also as uy. That is the y component of initial velocity. And we already have uy. So why we need to find alpha? We don't need. 2 into 1 by 9.8. That is 0.204 second. And now range. I showed you how this formula comes. See, time of flight into ux, x component. So 2u y by g, 2uy by g into x. So that will give you 2ux uy by g. 2 into root 3. See, we have ux already. So 2 into root 3 into 1 by 9.8, that is 0.35 meter. So this is very important in solving MCQ faster. This is nothing. This is just the manipulation of the earlier formula. Just don't take it as a shortcut, because you need to know how this formula comes. If you just remember one formula, and if you make this habit of plugging in numbers inside formula and trying to solve them, you will be in trouble. So you need to know the concept behind it. Now the next thing is calculation of maximum height. At the maximum height, vertical component of the velocity is 0. What do I mean by this? Vertical component of the velocity is 0. See, initially the vertical component is u sine alpha. Now this u sine alpha is in the upward direction, that is uy, and it is being acted with an acceleration due to gravity, that is g, in the downward direction. So what will happen? Naturally Vy is equal to uy minus gt. So this Vy will be going down as time increases. It will decrease. So it will, here it is something like this, then it will decrease. It will decrease. Finally there will be no uy. So when the vertical component of the velocity will be 0, the particle, the projectile, will not be able to go up further because it has no velocity. There is no, so how can it go up further if there is the velocity is 0? So it will become constant. So here only this Vx will be there, and you know Vx is equal to how much? That is ux. Vx is equal to ux or u cos alpha. That is constant. This x component of the velocity will be constant throughout the motion. So let's find out. This is nothing, we'll just use the third equation of motion, that is v square is equal to u square plus 2as. Here this s will become y because we are finding the y component, and everywhere a subscript y will be used. Now ay is minus 2g. Minus 2g we know. Final velocity will be 0 in the y component. Uy will be u sine alpha whole square. Minus 2gh when y will become h, because when vy will be 0, the vertical component of the velocity is 0, y is h. So maximum height h will be, after solving this, u sine square minus 2gh, it will be u square sine square alpha by 2g. U square sine square alpha by 2g. This is the formula for maximum height. Also we can write this. See, u sine alpha whole square, u sine alpha is uy squared by 2g. So in case of any vector form, you can directly do the sum from here. So that is how we calculate the maximum height. So height is maximum height is maximum when alpha is equal to 90 degree. That means you are projecting it directly above your head. Now I have a question to the viewers. At what angle of projection is the range maximum? This is a very easy question. Just you need to answer me. For the angle of projection, alpha is, at what value of alpha is the range maximum? So you will be giving me in the comment. And also the other question, that is, what are the two angles, or rather the condition of the two angles for which the range is same? Like I am projecting a projectile with certain angle, say alpha 1, and also another projectile with alpha 2. Both the case the range will be same. So this I want to know from you guys. So please comment below the answer. Now the last topic for today, that is the equation of trajectory. First of all, what do you mean by a trajectory? Trajectory means the path the projectile is following. That means the equation of the path. That means we will deduce an equation from which we will relate y with x. That means let's say y as a function of x. We will just find the equation of the curve. So we shall eliminate the time t. We will just find y as a function of x. So let's do it. See, we have two equations. X is equal to u cos alpha into t. X with respect to time. From there we get t is equal to x by u cos alpha. And displacement of y with respect to t. Y is equal to u sin alpha t minus half gt square. So we have two equations. Now what we can do is that we can eliminate this t. Like we'll put this t into this equation. Let's see what happens. So we have put here t is equal to x by u cos alpha, and after solving this we get y is equal to x tan alpha minus half gx squared by u square cos square alpha. This is the equation of trajectory of a projectile, and we can see this is parabolic. How can we conclude that it is parabolic? Because here the power is 1 and the maximum power is 2. So we can conclude that this is parabolic. So under the influence of gravity, the motion is parabolic. This is a very important MCQ. This comes in JEE, NEET and other exams. So, but why are we learning the equation of trajectory? So let's solve a question. The question is, the equation of a projectile is given as y is equal to 2x minus 5x square. Find alpha and u, where alpha is the angular projection and u is the initial velocity. And g is equal to 10 meter per second square. It is given. Now let's solve this. First of all, tell me, from this equation, what can you guess? This is the equation of a parabola. And how can we find alpha? How can we find u? we'll compare this with the standard equation of projectile. Then we can easily get it. Exactly that only I have done, as I said. Comparing with the standard trajectory equation. That is, what is the standard trajectory equation? Y is equal to x tan alpha minus half gx square by u square cos square alpha. So, and we were having y is equal to 2x minus 5x square. Now see here. Here is tan alpha, here it is 2. So tan alpha is equal to 2. So alpha is tan inverse of 2. In the options, it will be tan inverse of 2 only. You don't need to find out the angle. Now, we will find out the coefficient of x square, that is minus 5. And here it is minus half g u square cos square alpha. So half g u square cos square alpha is equal to 5. Minus and minus will cancel. So g we are putting the value as 10. This is 2. This cos square alpha, I have put it in the numerator as sec square alpha. I'll tell you why. And it is 5. So 10, 2 and 10 will cancel with as 5, and 5 and 5 will cancel. So u square is, this u will come here. U square will be cos sec square alpha. Let's make it neat. Now here u has come here, and 5 and 10 will be 2, and 2 and 2 will cut. So u square will be sec square alpha. So 1 plus tan square alpha is u square, and we already know tan alpha is 2. So u will be 1 plus 2 square whole root, that is root 5. So by comparing we can easily do it. Now one more question, one more variety of this trajectory equation. This is also important. I will show you in another question. Y is equal to x tan alpha minus half gx square u square cos square alpha. Now let's take common x tan alpha. So here I will be taking common x tan alpha, and in the numerator we have to multiply x tan alpha. So cos alpha into tan alpha, that will become sin alpha. So x tan alpha I am taking out. So 1 minus gx by 2 u square cos alpha sin alpha. Now we know range is equal to u square 2 u square cos alpha sin alpha by g. Exactly the same thing is written here. It is 1 by r. So y is equal to x tan alpha 1 minus x by r. This form is important. Just let me show you one question. I have a projectile. It is being projected with a velocity u, and angular projection is alpha. This is x, this is y. I am drawing a triangle here. Now let's say this is theta 1, this is theta 2. Now I have to prove tan alpha is equal to tan theta 1 plus tan theta 2. So how to prove this equation? Tan alpha is equal to tan theta 1 plus tan theta 2. This I will prove in the next video. So this is a very important formula, and I will show you how to prove this using that variation of the equation of trajectory. So that's all for today. Thank you for your patient hearing, and please leave your doubts in the comments, and also my WhatsApp number will be given in one of the comments, so please check it. Please send your doubts in the WhatsApp also if you are interested. So thank you. Please like the video and please subscribe the channel if you find our content useful. Thank you.